So how do we measure salinity? Determining salinity is basically you have to evaporate the water in some way. Early methods were that you take a water sample, you evaporate the water and see what remains. Obviously this is not very accurate because, as we said, some dissolved gases also contribute to the total salinity, and some of the constituents may also evaporate away. So the early technique was limited by the technology at the time, and it was also labor intensive, so you would take the sample, evaporate, wait, and so on. So not very accurate, very labor intensive. But one thing we have to remember is pure water, even though it's polar, it's not a very good conductor. If you put two electrodes into water, the positive and negative sides of the polar water molecules just stick to the electrodes, and electricity doesn't flow very effectively at all. On the other hand, if you have constituents or salts in the water, then conductivity is higher. So it's very easy to determine the amount of salts in the water by looking at the conductivity of the water. So salinometer basically uses this principle. The figure shows that fresh water, the bulb is not lit up, which means the current is not flowing, whereas when you have salt, you can connect it to a battery and the bulb lights up, so electricity is flowing. So in the ocean, you have instruments called, for example, CTD, current, thermometer, and depth. So you measure salt, temperature, and depth or pressure using these so-called CTD instruments. So one of the ways to measure salinity is with the salinometer, which is basically a measure of conductivity. So CDD is conductivity, temperature, depth, not current. Conductivity, temperature, depth. So determining salinity can also be done by using the principle of constant proportions, as I mentioned before. So you use chemical titration. As we said, we know the ratios in which chloride, sodium, magnesium, and other things occur. So you take a sample and measure the largest constituent, like the chloride, and you just use these constant ratios to estimate the other constituents. This works because pretty much anywhere you go in the world ocean, this proportion of salinity is constant. That's why it's called principle of constant proportions. So this method is used to measure amounts of halogens like chloride, bromine, iodide, fluoride, and so on, which is called chlorinity altogether. So salinity is basically 1.80655 times chlorinity, which gives you the total amounts of salt, parts per thousand, as we said, right? We will see later on that the range is not just 35, it varies, can be as high as 100 in some places where there is a lot of evaporation and salt is left behind. Those are called hypersaline places. Can be very fresh, where the rivers come out, for example, could be very low, like less than 20 parts per thousand, and so on. So pure water versus seawater, what are the properties? Even though there is only 35 grams for 1000 grams of seawater, the properties do change. So you can look at pure water and 35 parts per thousand seawater. You can look at the color in small quantities and large quantities. You know the ocean looks blue, or if the lake is very big, it also looks blue-green, because the water molecules scatter the light that's falling into the water body, preferably at those wavelengths. So what hits your eye is what you see as the color. So both of them are similar in color. The pure water has no odor, whereas the ocean water, as you get near the ocean, you begin to smell the ocean. Has a very distinct marine smell. Pure water is tasteless. In fact, to make water taste better, purified water, for example, adds back some minerals. So pure water has no taste, whereas with some minerals actually it tastes better, and some of those minerals are also essential for your body, for your blood circulation, and so on. So ocean water is obviously very salty. So small amount of salt, just 3.5% can make it actually undrinkable, and it can be bad for your body if you drank it in large quantities. We will see why that happens. The pH, we'll define pH a little bit later on, is 7 for pure water. It's neutral, whereas all the salt in the seawater actually make it alkaline. So surface waters range in pH from 8 to 8.3. On average, the ocean has a pH of 8.1. This is very important because all the life in the ocean depends on pH, and if you increase carbon dioxide in the atmosphere or do other funny things, you change the pH, which is very critical to understand. It's not a good thing, so we will see. But ocean has maintained this average pH for 100 million years or longer because salt in the ocean is basically conserved. It doesn't change very much. Density, maximum density at 4 degrees for pure water is 1 gram per centimeter cube, as we saw before. It is about 1.028 gram per centimeter cube for ocean water. Pure water freezes obviously at 0 degrees, whereas the salt reduces the freezing point, so the ocean water freezes at minus 1.9 degrees centigrade. So the coldest waters at the bottom of the ocean will be not frozen, but they will be less than 0 degrees centigrade. Boiling point also is increased just a little bit because of all the salts. So the open ocean salinity goes from 33 to 38 parts per thousand. This is written wrong here, parts per thousand. Coastal areas, salinity can get much higher. What we call brackish water is in salt marshes and coastal regions and so on, where the salt is much less than the ocean water, but it's still much higher than pure water or river water. Hypersaline waters like the Dead Sea and some coastal regions can be so high that the density is enough to keep your body floating. So you can see the image here. The salinity is so high and the density is so high because of that the a person can easily float on the surface. So salt is very important. Salinity is very important for life, as we will see it. And despite the Earth being covered with ocean, we still face a lot of water issues, obviously, because ocean water is not easily consumable. We have to desalinate it. We'll look at some desalination issues a little bit later on. So salinity, very important.